We're going to use the quadratic formula. Again, if you don't know the quadratic formula, this is where you would want to click on this explanation button because it's going to give it to us in here. And we want to also understand the standard form, the equation we're looking at. So this is ax squared plus bx plus c equals 0. So this is the form that we should be looking at when we're doing this. And then the quadratic formula is x equals negative b plus or minus b squared minus 4ac divided by 2a. And this seems, I know with some students they get a little bit overwhelmed because it seems a little bigger. All we're doing is taking some numbers and plugging them in. So if my coefficient in front of x is this b, that's what the b's gets replaced with. And then the same thing with a, it's the coefficient in front of x squared. C is my constant at the end. So we're just replacing them and we're working this out to the end. And we will have two answers just like this. Be careful about actually completing this one because seeing as I can see these here, these square root options, they don't want us to round anything. They're not telling me to round anything here. So that tells me that they're looking for more of an exact answer, which means I will have a square root, unless by chance I end up with a perfect square. So let's go ahead and practice this. 2x squared minus 5x minus 1 equals 0. I have a, b, c. So I'm going to go x equals negative b. So don't get rid of this negative. It's negative and then another negative 5 because b is negative 5 plus or minus negative 5 squared minus 4. This is always going to be 4 times a, which is 2, times c, which is negative 1 over 2 times a. All right, so let's reduce this. So negative, negative, that's a positive 5. Plus or minus, we get 5 squared is 25. Negative 4 times 2 is negative 8 times negative 1 is positive 8 over 4. And then 5 plus or minus. So we have 25 plus 8, which is 33. So that's definitely not going to be a square there, over 4. So there's really nothing I can reduce here. 5 and 4 don't reduce into each other. 33 doesn't have any squares that I can pull out of there. So I just need to type this in. Remember, this is two answers. I have 5 plus the square root of 33, and I should have put this into a fraction, so I'm going to highlight the whole thing. Click fraction over 4, and then I'm going to hit comma and do the same thing. It's going to be 5 minus the square root of 33. So I need to separate these out because there is no plus minus button here, right? So I have to type them both in this way. Plus minus, when we do it this way, it's kind of a quick way to show that there's two answers. But a lot of the time you have to type it in separately on the program. Alrighty, so a couple more of these. Try not to have to rewrite all of this. So use the quadratic formula to solve for x. So we have 6x squared minus 8x equals 1. Ooh, we want it to equal 0, so I need to subtract that 1 to the left side there. So if I subtract it on the right side and subtract it on the left side, I end up with 0 there and then minus 1 over here. So now I have a, b, c. And I can start plugging this in again. So it's negative b, so negative negative 8, plus or minus the square root of b squared minus 4ac over 2 times a. So again, I'm just filling in a whole lot of letters there. I know a whole lot of variables, but I'm filling them in, and now we have to go through and work them out here. So negative 8 is actually positive 8, plus or minus 8 squared is 64. Negative 4 times 6 is negative 24 times negative 1 is positive 24 over 2 times 6 is 12. So 8 plus or minus, let's see, we have 64 plus 24, and that gets us 88 over 12. All right, the next part here does say round to the nearest hundredth. So they do not want me to leave it in radical form. So I'm going to come back to my calculator here, and I'm going to go 8, if it'll let me, 8 plus the square root of 88. And I'm going to go ahead and hit equals, because if I don't put this in parentheses, if I just hit divided by, it's going to do something funny there. So if I hit equals and then divided by 12, then it'll show up correctly. And I want to go to 100th. So that's the 44 there, but this next number is an 8. That's 5 or bigger. So it's actually going to be 1.45. And then I'm going to do 8 minus the square root of 88 equals, and then divide by 12, just so that, again, I don't have to deal with that issue. The 100th would be the 11, but that next number is a 5, so it's going to be negative 0.12. Check. All right. And this is definitely necessary to use this formula once you get to these types of parabolas where you don't have the nice integer answers anymore. I can't just factor this the way we were before, where we had, you know, the two parentheses like this, and I was saying, breaking it apart into, you know, what numbers of 6 and 1 can multiply together to get the correct beginning and end number, but add to get 8. I'm not going to be able to do that when I have to have these decimals that are going down to the 100th. That would just be impossibly, you know, time consuming there to even try to do that once you start to get to decimals, because we're talking about hundreds of numbers here if we're going down to hundredths. So we don't want to have to do that once we get to this point. We want to be able to just plug it into a formula now that we understand the idea of factoring. Okay, so now we want to look very specifically at a part of the quadratic formula, and I'm going to go ahead and switch over. Oops, I didn't mean to click on that guy. Switch over to red here. We're going to look at this piece under the square root sign. This is called the discriminant. And why we want to look at this one is it very quickly tells us whether or not our answer is going to be two real solutions, which if we're looking at a coordinate grid here, two real solutions means it looks something like this, where I have it crossing the x-axis twice. If we have one real solution, it means that it was kind of touching right there on top of, so it's just right on the x-axis. And these could also be negative. They can open down as well. If we have one that's not touching the x-axis at all, so I'm showing you the downward one, this would be imaginary roots. And I think they only want us to identify 2 or 0, or 2, 1, or 0 for real roots, I'm pretty sure is how they want us to identify this. So we either have two real solutions, which is this first one I drew, one real solution, which is the second one I drew, or no real solutions, which is this one down here that's not on the graph at all. And that means that we ended up with a negative number here. So if I kind of back this up a little bit, if it equals a positive number, basically, positive number. So if the discriminant equals a positive number, then you have two real. If it equals 0, then you have one real. If it's a negative number, and remember that means that this is under a square root sign. So if we have a negative number under a square root sign, just like we were learning a few weeks ago, that's an imaginary number because we can't really have the square root of a negative number. It doesn't make sense if we think about how did it get there. It would have to be a number times itself, which is either both positive or both negative. You can't end up with a negative number. So that's why we have this imaginary number to deal with that situation. But in this case, we're just saying that that's 0 real answers. So we're going to go through and we're going to solve this, and I'll switch up. Let's see, we'll go with orange, I guess, here. Or you know what, I'll go with bright blue, why not? So all we're going to do is the discriminant on this one. X squared plus 7x minus 1 equals 0. So we have A, B, C. So I still have to look at A, B, C because they're all in here. But now I'm going to go B squared minus 4 times A times C. So all I care about is this answer here. So that's 49. Negative 4 times 2 is positive 8 times negative 1 is negative 8. So now I have positive 41. So that's a positive number, and I want to type this in, positive 41. And since it's a positive number, I'm going to have 2 real solutions like that. I can click check. So this is just a very quick way to see how many solutions. No matter what, I actually know I'm always going to have 2 solutions to this, but if it was a negative number, they just wouldn't be real solutions. And if it's a 0, it actually means that it'll be a double root. So that's why we only have 1 actually shown, and we can actually see that when we work it out. But it just means that it's a double root.